Mr. Idris. How are you? Hope that you're doing great with all the crazy things going on. Today, I'll be talking about one of our solar system's largest explosive events, solar flare. How do they occur and their effects on Earth? My name is Maryam Ammar and I hope you enjoy it. So let me give you an introduction about solar flares. Solar flares are sudden releases of energy from the surface of the sun. It releases the equivalent energy of millions of hydrogen bombs, all in anywhere from a few seconds to an hour or so. In other words, a solar flare is a sudden flash of increased brightness on the sun, usually observed near its surface and in close proximity to a sunspot's group. The energy of a flare is released in the form of electromagnetic radiation, in radio waves, visible light, gamma rays, and other types of waves. The electromagnetic energy and the energetic particles from a solar flare get sent out into space and can intersect with the Earth. Inside a flare, the temperature typically reaches 10 or 20 million degrees Kelvin and can be as high as 100 million degrees Kelvin. So if you think about it, the sun is a very big collection of explosions, and as you can see on the left of this slide, you can see a solar flare of this magnitude, which is a portion of the sun's size. So we can conclude that it is definitely one of the biggest explosions in our solar system. The sun is a roughly spherical collection of highly energetic charged particles that swim around in gigantic flowing currents that create a complex magnetic field. The magnetic field in turn drives the motion of the charged particles. The result is an interact dance of energetic particles swirling throughout and above the surface of the sun. When those dancing streams of particles swirl against each other, they trigger a sudden change in the path of the sun's magnetic field. That sudden change releases energy, resulting in a solar flare. So basically, in other words, a solar flare occurs when accelerated charged particles, mainly electrons, interact with the plasma medium. And so, I would like to add that solar flares occur in a power-law spectrum of magnitudes. So an energy release of typically 1020 joules of energy to produce a clearly observable event. The explosive heat of a solar flare can't make it all the way to our globe, but electromagnetic radiation and energetic particles certainly can. So those charged particles from a solar flares can temporarily alter the upper atmosphere, creating disruptions with signal transmissions from, say, a GPS satellite to Earth, causing it to be off, and also it causes the northern lights and many other effects. Effects on satellites. Modern society relies on satellites for everything, from telephone communications to GPS tracking, and a powerful solar flare could significantly disrupt or even destroy many satellites. Satellites in a high geosynchronous orbit could be easily damaged by a powerful electromagnetic current coming off the sun. Ultraviolet radiations from the flare event could also heat up the Earth's atmosphere, making it expand, which would result in an increased drag on orbiting satellites. Modern satellites contain protection against electrical disruption, such as built-in Faraday cages. But flares can block signals to and from satellites, and in some rare cases, shut them down completely. This can lead to communication disruption on Earth, shutting down international telephone links and television satellite feeds. Atmospheric displays. Addition to affecting human activities, solar flare activity can also ramp up natural phenomena such as aurora borealis and aurora australis. The aurora borealis and aurora australis light show can normally be seen for almost of the year and is driven by a stream of particles constantly emanating from the sun. When these particles interact with the upper atmosphere, they excite molecules in the air, and when these molecules come back down to their unexcited state, they release visible light. So when a powerful solar flare event sends a high amount of charged particles into the upper atmosphere, the aurora, which is normally visible in higher latitudes, extends further south and is more active and more intense. Power grid damage. Although technology allows people to convert the sun's energy into electricity, the same source of energy is also capable of completely knocking out the energy grid, potentially leading to catastrophic conditions. Electromagnetic energy from a flare event is capable of charging the atmosphere. This phenomena would in turn induce an abnormally high charge in power lines, blowing out both power transformers and stations. Destruction of power grid would lead to many different kinds of problems for society, including a loss of ability to refrigerate food items and the waste processing items. Increased lightning strikes. So, according to a 2014 report from the researchers at the University of Reading, increased solar flare activity can lead to an increase in the number of lightning strikes. So the more the solar flare occurs, the number of lightning strikes increases. So now, let me point out few things that are very interesting facts about solar flares. The fastest ejection reaches Earth in less than 2 days. And that sounds a long time for you, but for the damage that it causes, it's a really short time. They release 10 million times more energy than a volcano. And you already know how much one volcano can cause, so imagine 10 times more. During peak times, there are over 20 solar flares a day. And this is scary because one solar flare can cause many things, so imagine 20 or more. They are almost as hot as the core of the sun, and you already know the normal sun, how hot is it. And yeah, thank you. I hope you enjoyed it.